All right, good morning. So you should have just finished this worksheet that looks like this, and I just want to talk a little bit about some of the patterns that you should have figured out from going through this worksheet. So the first one, you'll notice right here in the lithium box that this one is kind of completely filled out for you. So it has the name, lithium, followed by the atomic number, has the electrons shown in their correct locations, as well as the number of electrons in each spot. Okay, so you'll notice that there are 2 electrons in the first ring and then 1 in the second ring. And as you follow along and see the patterns, you should have noticed that the 2 electrons is the most that is in that first ring anywhere. Okay, so that will always be the first number in the pattern of the correct arrangement of electrons, is 2 in the first ring if there are 2 electrons. With the case of hydrogen up here, there is only 1 electron, so there's just 1 there. Okay, so then you look at beryllium, which is the next one with 4 electrons. It has 2 in the first ring and 2 in the second ring. So I'm going to try to show this here. Okay, there's my X. Okay, so 2 in the first, 2 in the second. And as you go left to right, you will notice that you get 1 more electron for each atom going across. So again, 2 always in the first string, and then you'll notice that as you go across, you are adding 1 more electron in the second ring. Okay, then as we go down to the next row where sodium is, you see that it is 2 followed by 8 followed by 1. Okay, so now you may have started to see the pattern that there is 1 electron in the outer shell of each atom in this group. Okay, that is one of the patterns that you should have noticed, is that each element in a group going up and down has the same number of electrons in its outer ring. Okay, so here 2, 8, and 1, I'm not going to draw all of them in. I'll put 2 in the first, there should be 8 in the second, and then 1 in that outer ring. Okay, and then again, as you go across, 2 followed by 8, and then 1 more electron, 2 in the outer ring. So then here for silicon, 2, 8, 4, 2, 8, 5, 2, 8, 6, 2, 8, 7, and 2, 8, 8. Okay, so again, 8 in the second ring, 8 in the third ring. And then we loop back around to potassium, and we have 2, 8, 8, followed by 1, because everything else in the first row has that 1 there. Okay, we only go up through calcium because once you get past calcium, you start getting a little trickier with the arrangement, but for these first 20, the patterns emerge. So again, patterns that you should have noticed is things in the same column have the same outer number of electrons. Okay, and the things in the same row going from left to right, you are adding 1 electron as you go across. Okay, so one of the things that we notice here is we're going to talk about what's the most important electrons. Okay, and those most important electrons are what we call the valence electrons. Okay, valence electrons are the electrons in the outermost energy level. Okay, so for what we were looking at up here, that would be those number 1 electrons in this group, the 2 electrons in this group, etc., going across. Okay, and the reason that they are the most important is because these electrons determine an atom's chemical behavior and properties. Okay, so from here on out for the year, we'll be focusing our majority of our time on these valence electrons. Okay, and one of the really simple ways that we can show valence electrons is with what we call electron dot diagrams. You may have seen these in the past. Okay, what it does is it shows only the element symbol and a dot for each valence electron that it has. Okay, so if we go back to our worksheet from before, the valence electrons are these number 1 electrons that I circled for this group, the number 2 electrons that I circled here, and then 3 for this group, 4 for this, 5, 6, 7, and 8. Okay, with the exception of helium, which only has 2. So an example here is rubidium. Rubidium is in the first group with lithium, sodium, and potassium, which had only 1 in its outer ring. So we write the symbol Rb, and then we put 1 dot to symbolize that 1 valence electron that it has. Okay. Second one we have here is bromine. Bromine is in the same group as fluorine and chlorine, which has 7 valence electrons. So in this case, we draw 7 dots around it. Okay, one of the things with when you start to get more than 1 dot, you put 1 dot on each side. Before you double up with 2 dots. Okay, this just has to do with the fact that electrons are negative and they want to be as far apart from each other as possible. Okay, so the next thing you're going to do today is using the blank periodic table that you find on Schoology, is you are going to take these dot diagrams and you are going to fill in for these elements here that I boxed and these elements here that I boxed. Okay, so filling in with electron dot diagrams for all of these atoms. Okay, now using the patterns that you figured out on the first worksheet, this should be pretty simple. So if we take rubidium, which we just did, it is element 37 over here. Okay, so I'm going to put in the symbol RB, and then I'm going to draw the 1 dot there. Okay, so our second one then is bromine, which is element 35. Okay, so we put our BR here, and again, 1 dot on each side, and then you can double up with the 2 dots. Okay, so continue putting in dot diagrams for those 2 chunks of elements, following the patterns that you figured out on your last worksheet.